Alright, remember, welcome back. Remember we said in modular arithmetic we always wrap up at a particular number. The same principle applies to multiplication. So for example, if we are told to multiply a particular set of numbers in a particular modulus, all we do is we divide and write the remainder. Very simple. Alright, so for example, we are asked to do 8 times 6 in mod, for example, let's say mod 7. Mod 7. Alright, now, so I told us that initially that this sign means multiplication. In modular arithmetic. So this question is going to be, this by this is 48, but in mod 7 is going to be 48 divided by 7, that is 42, and 42 minus this is 6. So the answer is 6. 8 by 6 in modulo 7 is 6. Alright. Number 2 example says, let's say if I have 13 times 10, for example, in mod 3. In mod 3. This is also very simple. What we have to do is 13 times 10 will give us 130. So if we divide 130 by 3, that is going to give us 130 over 3. That is going to give us around 4, 1 and 3. That's 43. 43 remainder 1. So the answer is going to be 1 mod 3. 9 by this 12, right? So the answer is 1 mod 3. You can imagine 13 times 10 is 1, alright, in mod 3. Alright. And that is to tell you, because now in mod, it doesn't mean that now in mod 3 it means that there are many other numbers that's going to give us 1. So for example, I do 4 times 10, for example. 4 times 10 is going to be 40. So 40 divided by 3 is 13 remainder 1. So it means that it's going to be 1. So 4 times 10 in mod 3 is going to be 1, as well as 13 by 10 in mod 3 is going to be 1. So it means that 130 and 40 are the same in mod 3. So they are written like this. 130 is congruent with 40 in mod 3. You can call this congruent or equivalent to. So 130 is equivalent to 40 in mod 3. That's what it's telling us. And there are so many other. It means that 10 as well. So because if we do 10 in modulo 3, 10 in modulo 3 is also the same as 1. So it means that 10 is going to be congruent with this. Other numbers like that, maybe even a lot of numbers like that are going to be congruent with themselves in modulo 3, as far as they are going to give us the same answer. Alright, so when a set of numbers give us the same answer in a particular modulus, we say that they are congruent with one another, or they are equivalent to one another. Alright, so that's basically modulo, multiplication involving modulus. Alright, you could now be asked to do multiplication table, to set a multiplication table in modulo. For example, let's set a modulo 6 multiplication table. That is going to be like this. We'll put this sign here, multiplication. So, and then we'll draw our table. So, we have 0, 0, 1, 2, 3, 4, 5, 6. Alright, so this is where we're going to draw a table, and then we have 1, 2, 3, 4, 5, and 6. Alright, so we now begin to multiply. Now to begin to multiply, you have 0 times 0 is going to give us 0. Of course, 0 times 1, 0. 0 times 2, 0. 0 times 3, 0. 0 times 4, 0. 0 times 5, 0 and 0. Alright, so everything under 0 is going to be 0. Alright, now the next one, 1 times 0 is still 0. Well, now 1 times 1 is what? 1. Now because it's not greater than the modulo, this multiplication table of modulo 6. Now, 1 times, because the answer we got is not greater than 6. So we write it there. It's not 6 or greater than 6. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 4. 1 times 5 5. 1 times 6 is as big as the modulus. 6 is the modulus. So because of that, we wrap up at that and give it 0. Remember, the principle is simply to divide. We get 1, remainder nothing, that's 0, so we write the remainder there. Alright, then 2 by 0, of course, still 0. Everything here is going to give us 0. It's going to be this times 0. Alright, then 2 times 1 is going to be 2, 2 times 2, 4. Now 2 times 3, we get 6, we wrap up and we have 0. 2 by 4, 8, we wrap up and we get 8. We are going to divide by 6, we have 1 remainder 2, so we write the remainder. Then 2 times 10, 5, 10. Divided by 6, we have 1 remainder 4. So we write our remainder 4. 2 by 6, 12. Now 12 is a multiple of 6. So of course, we are going to have 0 here all through. So it means that all of here is going to be 0. So basically, it's going to be 0. And 6 times anything is going to give us 0 too in the modulus. So in order not to have a circle of 0 like this, we could just stop at modulo 5. Alright, so 3 times 1 is going to give you 3. 3 times 2, 6 again, we wrap up and we have 0. 3 by 3, 9, we wrap up, we have 3. 3 by 4, we have 12. We wrap up and we get 0. 3 by 5, we have 15. Divided by 6, 2 remainder 3. Now notice that, okay, let's continue first. We are going to see something. 4 times 1, 4. 4 times 2, 8. We wrap up, we have 2. 4 by 3, 12. We wrap up, we have 0. 4 by 4, 16. We wrap up, we get 4. 12 minus that, we get 4. 4 by 5, 20. 20. We wrap up, we have 2. So there is always a sequence. There is always a sequence. Notice here, we have 0, 0, 0. Here we have 1, 2, 3, 4, 5. At the end again, if we had continued to 7, 8, 9, we're going to begin to have 1, 2, 3, 4, 5 again. The sequence is going to repeat itself. Notice here 0, 2, 4, 0, 2, 4, 0, 2, 4. That's how it's going to repeat itself. Here 0, 3, 0, 3, 0, 3, 0, 3. It continues like that. The next one 0, 4, 4, 0, 4, 2, 4, 2, 0. That's 4, 2, 0, 4, 2, 0, 4, 2, 0. It's going to repeat itself. And the same for 5. 5 is 5 by 1, 5. 5 by 2, 10. We have 4. 5 by 3, 15. We have 3. 5 by 4, 20. For 20 is going to be 2. 5 by 5, 25 is going to be 1. Okay, notice at 5, at 1, if we went 1, 2, 3, 4, 5, here we are going in descending order. So that sequence is going to repeat itself if we had extended the table. So that is it for multiplication in modular arithmetic. Alright. So now we're going